I've gotten multiple comments that are like, this girl's just stringing together buzzwords. So let's talk about it. What is quantum machine learning? So as of right now, there's two main types of learning that people are familiar with. There's machine learning and then there's deep learning. And what I'm going to do first is I'm going to define learning for those of you that are new to this. Learning in terms of computational work means pattern recognition. And in the simplest way, this can be image recognition, voice recognition, or I'm trying to figure out what plants are in this image, etc. Feature recognition for the matter. So we have machine learning and deep learning. Machine learning just takes data sets and you don't have to program a computer completely. The computer with your data set can go along and analyze features. Deep learning, on the other hand, introduces neural networks, etc. Now, if you're watching this video, I assume you have some knowledge of machine learning and you probably don't know much about quantum computing. So you're probably familiar with the fact that machine learning uses binary bits. You have zeros and ones. Well, quantum computing applies the laws of quantum physics, where you have qubits. And I'll explain what a qubit is real quick. A qubit takes into account superposition. So instead of just having 0 and 1, you now have an intermediate simultaneous state where 0 and 1 exist in one frame. And through this method, you are actually able to recognize more complex patterns, and it completely revolutionizes to some degree how we understand and work with machine learning. Back to this figure. So as you can see, in terms of recognition, machine learning has this linear pattern, but quantum computing can actually calculate multiple pathways in terms of getting to the same end product. Here's where the usage comes in. So I'm using a QML model to predict protein misfolding and aggregation. So I'm not going to go into the biological details. I will in a later video if you'd like me to, but this model essentially goes in and I have programmed, for example, P53 and predicted mutation sites actually within P53. So this paper is still in publication, so I'm not able to post all the figures, but once it's published, I can talk more about the methods that I used and the outputs. Here's a fantastic textbook that got me started on QMLs, and I would recommend you read it too if you are interested in working with them. I hope this answers your question. This was definitely an oversimplified version. I can make a more complex version, but let me know if you have any questions.